Okay, so the question was asking us what was the average coefficient of the friction. Okay, well, so since the person was going up a surface like this, okay, this 19 degree, the length of the surface is 15 meter. Okay, so let's say if the person is right here, so it will experience a downward gravity, and the perpendicular to the surface, there's an upward force, which is the normal force, okay, to the person on the surface. Since it's going upward, there's a friction along the surface. Okay? Sorry. So now we can come up with a energy conservation law according to this kind of graph. Okay? So first, let's clarify the force, each force. Okay? So gravity is just mg. Normal force, let's say, let's use n then. Okay? Instead of Fn, let's use n. So normal force is equal to mg cosine theta, or cosine 19 degree, okay? And the friction is equal to mu k times the normal force, which is mu k times mg cosine 19 degree. Remember, there's the height of the such things here, which is, so the height of the things here is, let's say this is the height, h, okay? H can be equal to, if we said the length of a surface, which is 15 meters, is d, okay, let's say this is d equal to 15 meter here, okay? So the height would be d sine 19 degree, okay? So according to energy conservation law, we'll have initial potential energy is mg hi initial plus initial kinetic energy, which is 1/2 mvi squared, minus the energy loss due to the friction, just simply minus fd, which is the work done by friction, okay, is equal to final potential energy, which is mghi, h final, okay, plus final kinetic energy, which is 1/2 mv final squared, okay. So we know initially it was at the ground, so the initial height is 0, so hi is equal to 0, okay. So this thing here is equal to 0, and there's initial speed, which is 11.0 meter per second, okay. So this exists, and the final speed is 0 because when she reached the top, it stay at rest, okay. It said and glides 15 meter up along this slope before coming to rest. So when the skier reached the top, it stopped. So the final speed is 0, and this will give us 1/2 mvi squared minus fd is equal to mg hf plus 0, so just 0, okay. So this is the equation. We know initial speed was given as 11.0 meter per second. So well, why don't we do some arrangement here? Because we're trying to figure out the coefficient of the friction. So we can simply expand this equation, become a more specific equation, which is 1/2 mvi squared minus F is the friction, which is mu kn times d is equal to mg hf, which is the final height. Okay, and we can keep expanding. We'll get 1/2 mvi squared minus mu k. Remember, n was equal to mg cosine 19 degrees. So mu k mg cosine 19 degree times d, which is equal to mg h final, and h final, remember the height is equal to d sine theta, d sine 19 degree. So just simply mg times d sine 19 degree. In this case, h final is equal to h because eventually we reach the top, and from the top to the ground, the height is h, which is h final. So it's equal to d sine 19 degree. Okay, and we'll get mu k is equal to 1/2 mvi squared minus mgd sine 19 degree over mg cosine 19 degree times d. Okay, and you see we can take m out from the equation above the denominator, which is m times 1/2 vi squared minus g d sine 19 degree over mg cosine 19 degree times d. M and m will cancel out. Okay, and this will give us mu k just equal to 1/2 vi squared minus gd sine 19 degree over g cosine 19 degree times d. Okay, so now we can plug in the value. We know the initial velocity was given as 11 meter per second, so it's just 1/2 times 11.0 meter per second, and then the whole velocity square. Okay, minus g, which is 9.8 meter per second square, times d. D is given as 15 meter. Oop. Times sine 19 degree over g, which is 9.8 meter per second square, times cosine 19 degree times d, which is 15 meter. And this will give us mu k is equal to about 0.091. Okay, so that's the average coefficient of the friction. Okay, and thank you. This is my answer for the question.